Hey everyone, I'm Matt from Bridge Crew, and welcome to my talk, Automating Infrastructure Security as Code with Open Source. It's a pleasure to be here at Community Summit, and yeah, let's get into it. So I always find a little bit of context never hurt anyone, so we're gonna have a look at the how, what, and why of infrastructure as code security. Look at some stats from some kind of dependency management like data we've collected from kind of open source Terraform and Helm style repos for infrastructure as code. And then look at some open source tools and some automation and kind of, productivity style things that we can do to enable a DevOps team to kind of embed security in a non-blocking automated way. So maybe there isn't a dedicated security advocate on the team. Maybe there isn't a security team embedded with that DevOps team. What options do you have to spend a few minutes to enable automation to kind of take the brunt of that kind of security posture assessment work for your infrastructure as code? So we'll go through a few open source tools and then leave with some further guides and tutorials and kind of information that might be of interest. Would love any feedback on this. Please do kind of tweet me at MetaHertz. My details were on the previous slide, or come and join our codified security Slack for all things infrastructure as code security. We're at slack.bridgecrew.io. So yeah, a bit of context first. Why infrastructure as code security? And for kind of the cloud security gurus, apologies if this is, more of the same, but, context is always valuable, as I said, I find. Developer first cloud security. It's following exactly the same validation and usefulness that we found with merging dev and ops. Infrastructure as code in general is becoming best practice. We can define exactly what our infrastructure needs to look like. We can make it repeatable. We can make it testable by codifying that through any infrastructure as code framework, be it CloudFormation, Terraform, serverless framework, CDK, ARM, all of those Kubernetes manifests. Don't want to miss that one out, do I? We can codify our infrastructure to make it repeatable and to make it really easy to ensure that our test environments do actually match our prod environments, and see changes through Git commits and things like that. Just all the kind of sane stuff that we do with our application code bases. So as the cloud becomes kind of codified with infrastructure as code, it does add an opportunity there to scan that code in the same way we would scan for vulnerabilities in our npm or our Python environment. But at the same time, it also highlights that something does need doing there, because with infrastructure as code, with CI/CD, with the whole DevOps movements, we are now looking at deploying to production whenever there is a successfully built pull request or a successfully built push to our main branch. And traditional security teams that might kind of, take a proposed change and look at that in an environment or kind of do manual testing on that, that process is going to fall down at the rate at which we are deploying things nowadays. So not only is it an opportunity, by codifying our infrastructure, we have more chance of catching issues at an earlier stage in the deployment and catching things way before they make it into production. But also it's a necessity because the pace of change is now such that without automation, that person manually reviewing changes to potentially, thousands of containers to deploy, is going to be having a really bad day. The good news is there is a lot of open source software, which we will go through, which will solve a lot of these problems for us automatically. We can embed them in our CI/CD pipeline. They provide numerous ways to kind of get ahead of this, be it from just alerting, or be it from actually blocking the CI/CD pipeline, or even just looking at changes in incoming PRs to help guide teams on decisions to make to prevent bad configurations coming in. Before we get into that though, there is the kind of topic of, well, these bad configurations in infrastructure as code, it's just I'm just spinning up an EC2, or I'm just spinning up a couple of simple containers, or I'm just spinning up a couple of S3 buckets. Like, is there really that much? Like, I'm proficient in Terraform. Do I really need to add another thing to my CI/CD pipeline? And there's a few things. No one writes Terraform or CloudFormation or Kubernetes from scratch, I find. So if you've never, borrowed a small bit of sample code that came from somewhere and may or may not have ended up in production, then fair enough. But your teammates might have done, or the dependencies you're using might have done. And so, it's still better having that mindset of treating infrastructure as code. While it's simple, or while you might not be using that much of it, infrastructure as code does tend to grow, and it's still better to have something in place to kind of provide that checks and balances for if someone ever does do the standard O'Reilly copy and paste from Stack Overflow. I don't know why it's always Stack Overflow. There's so many other places to copy from. A number of them are on screen right now. So we actually did a little bit of research. We pulled down some data sets by scanning the kind of default configuration of things like Terraform modules in the Terraform registry, and ran them against static analysis for infrastructure as code. And like with most software projects, there are issues that are in regular usable modules. And so we found a lot of items were kind of misconfigured, because when you're looking at kind of ease of use and ease of setup, the security versus usability problem generally happens. If there was a Terraform module which required you to set up pages and pages of CAs and KMS and everything, with all the security settings set to the 11, what are the chances of people actually getting through the first README? But at the same time, on the reverse side of things, a very simple hello world example often makes it into a project, because the project isn't about the infrastructure as code. The project is about automating and deploying your application for your business for whatever the, sprints objectives are. So it's quite common for defaults in infrastructure as code to make it into production, which is why if you are using third-party modules, if you are taking infrastructure as code examples, it is important to have some way of kind of checking those before deploying. And I'll leave these in the slides so you can pause the video. But yeah, so we found some very interesting categories, and we are soon to be publishing another data set on Helm version 3 public repos as well, and looking at what we can do to improve the security posture of reusable items, just like you have kind of the built-in security scanner of NPM and things like that. Also, it's worth note actually on this slide that, and I should update this actually, see whether this trend continues, but at the start of lockdown, people clearly thought, do you know what I'm going to do? I'm going to write a lot of Terraform modules. Anyway, moving swiftly on. So yeah, it doesn't matter whether you are, very capable with infrastructure as code, or consider your infrastructure as code very simplistic and not really in need for security scanning. There's always dependencies. There's always the ability for that to grow. There's always defaults that might not seem insecure because there's nothing glaringly obvious in the description. But unless you're familiar with which defaults for a given module do or don't equate to true and what impact those have on security. For example, S3 buckets being non-encrypted by default unless you mandate that in certain modules with certain infrastructure as code languages. As a simple example, you might be leaving kind of logging disabled, which prevents you going back afterwards and identifying an issue. Databases might be unencrypted at rest. You might be leaving TLS 1.0 enabled. And just as those first four are important as security items on their own, generally speaking, you will scan your Docker containers for vulnerable microservices. So why not also scan your infrastructure as code? And with that, we are at the point where we get to deep dive into some tools. Spoiler alert, most of them are by Bridgecrew. But, we are very proud of our open source tools, and we'd love to get you involved and some feedback and see if these tools can really kind of help improve your infrastructure as code security posture. So the first one I'd like to talk about is Checkoff. Now, Checkoff is written in Python, and it's designed as a static analysis tool for infrastructure as code. So whether you are in CloudFormation, Terraform, Kubernetes, ARM templates for Azure, Helm templates now that we will effectively template out and spit out Kubernetes and then run those against the same Kubernetes checks, or even Terraform plan results. So that if you have variables coming from the infrastructure that are used within Terraform itself, we can kind of get higher resolution on those and scan those as well. So a multitude of infrastructure as code languages, and we have 500 plus built-in checks to kind of make sure that the defaults often taken from CIS guidelines for different cloud providers and Kubernetes are adhered to. And we will kind of provide you early warning in the style you're seeing being spat out in this lovely GIF on the screen right now. And we'll jump into a bit of a demo with this. But what this is basically going to allow you to do is run this anywhere. So multiple points along your pipeline. If you consider kind of, a regular simplistic CI/CD pipeline, we have someone making a change and submitting it to source control, GitHub. That will then trigger a CI/CD deployment, which might kick off any of these infrastructure as code languages after a load of testing to actually potentially make the change, or to have a approve deny stage to then make the change into a cloud account. Pick your favorite cloud provider here. It's AWS, obviously. And with the idea of the Linux principle of kind of do one thing and do one thing well, Checkoff is designed as a small Python application binary, and you can run it yourself. You can just kick it off from the CLI. You can put it as a pre-commit hook before you make any changes to any commit at all. You can run it as part of your CI/CD pipeline, and in fact we'll show that we have kind of GitHub Actions and built in wherever we can create a template to make people's lives easier for embedding this, we will. And so it really will run kind of wherever you need it to run. And the recommendation is you just run it at multiple points along your pipeline. To that point, let's jump into our first demo. So here we have a repo called TerraGoat. And another problem we have with infrastructure as code security, like anything in security, sometimes people don't really want to run security tools against their production code base, or kind of test things against their production code base from the offset. So we have written a number of vulnerable by default security training tools. So TerraGoat is one of them. We also have CFNGoat for people that prefer their infrastructure as code a little more CloudFormation based. And the idea with these is we are trying to cram as many insecure default, badly written pieces of infrastructure as code as possible into a single repo. You can see we have Bridge Crew infrastructure security badges here, which are very much non-compliant. And so if we kind of dig into this Terraform into AWS, and let's have a look, for example, S3 is always the favorite, isn't it? Let's have a look here. We will have buckets with unencrypted public buckets with no access logs and no versioning. We will have things that probably allow public writes. We will have all kinds of bad stuff. Equally, if we went and looked at EC2, there would be horrible numbers of credentials stored in configuration volumes and all kinds of other nasties for us to find, along with IAM with liberal uses of stars where there should be sensible sensible options. And so for anyone that's kind of had to go around and look for overly what's the word I'm looking for? Overly wide IAM policies. That one is definitely for you in IAM.tf. But the point of all of this is we can very quickly run Checkoff -d, and let's just run it recursively. We'll look through a directory for any infrastructure as code. And so let's just give it the Terraform AWS directory from TerraGoat. And what it's going to do is it's going to kick out a load of things we should be worried about, which obviously being a purposely vulnerable repo is going to be considerable. So here we have kind of issues flagged for the EKS cluster. the control plane not having logging enabled, the EKS public endpoint being accessible to far more people than it should be, secrets encryption isn't enabled, the public endpoint isn't disabled. Let's scroll up a bit, find some other resources. Security groups are allowing SSH access from everywhere rather than through kind of a bastion. We have issues with non-encrypted EBS volumes. Still not got to the S3 stuff, have I? It's always my favorite. We haven't enabled logging for lambdas. Yeah, as you can imagine, lots and lots of things. And for each issue Checkoff finds, it outputs this same format by default. So we assign each policy we scan for an ID. We provide a description. We provide the resource and file we found this in, as well as line numbers and an output of those line numbers if you want them. We also provide a guide for each issue we find, and the idea is to just provide some context for potentially someone who, first time looking at a infrastructure as code security issue, simple information, what to do if this issue has made it through to runtime, for example, is live in AWS. How do you remediate it from runtime rather than just correcting it in Terraform? And so, at its basic functionality, that's what Checkoff allows you to do. It allows you to really quickly get an idea of what's going on with the security posture of your infrastructure as code. We can also output in JSON, failed checks, pass checks, parsing issues, so that you can kind of go ahead and do more exciting and interesting things with the data. We also have a quiet mode, which will only show you failed checks as well as all the pass checks, which we didn't quite scroll up far enough for, and a number of other useful items. So you can specifically say you only want to find certain frameworks, skip a framework, select only a framework. Same with those individual check IDs. You can specify, I actually only want you to scan for certain policies. You can list out all the built-in checks and their IDs. We support a number of output formats, including JUnit, XML, and JSON. And we also support loading of policies from an external Git repo. So if the current policies within Checkoff, which are actually built into the code base, so you don't need to download Checkoff and then go and find a policy pack. It comes with the checks of the version you download. If you want to load in your own checks, you can do. If you then want to use a filter to actually scan just those checks rather than the entire default policy pack, you can do. So yeah, we support loading external checks. And because Checkoff is written in Python, all the checks are written in Python as well. And so we do have documentation on getting started with writing policies. If I could scroll down here. But one of the best things to do if you're interested in taking that approach is just go and check out the code base, or go and check out a recent community pull request, which has added a new policy. So if we go in here and look at, let's have a look at Terraform AWS policies, shall we? And you'll see them all listed here. And just kind of having a look into one of the policies. So does S3 have MFA delete on? You'll see they're quite simple with the check name and description, category and supported resources to scan embedded in here. And then, we have helper methods for checking an inspected key exists, or checking an inspected key has certain children with certain values, or you can branch out and just get the entire section as a dictionary to allow you to do more custom clever checks with things. But yeah, very easy kind of language to write checks in. And the reason it's in Python is we found that it was a perfect overlap between security teams that are used to writing their own automation for certain kind of security tasks, and development teams that found it really easy to kind of read and understand a Python code base. So generally speaking, we find it's a good in-between language, whether you are coming from the development side and starting to write policies and starting to be involved in infrastructure as code security, or coming from the security side and doing the same. Back to the slides. And yeah, so on the point I was making earlier about Checkoff runs anywhere. And this is really important because there is more available information the closer you get to runtime. Once you're in kind of production CI/CD, you will have the ability to see, production environment variables, or pardon me, the CI/CD pipeline will have the ability to see production environment variables, which may or may not affect the security posture. Maybe you're using those environment variables to set up security groups, or who does have access to what. At that point, you want Checkoff to highlight if you have, open internet access to the world, or you're still leaving something enabled that shouldn't be enabled. You might only be able to resolve those variables in your CI/CD pipeline because your Terraform or your CloudFormation is pulling in infrastructure variables. But equally speaking, it's a lot easier and less complex to fix issues as soon as they've just been written. If a piece of Terraform or CloudFormation hasn't even been committed to Git yet, if it's still just a glint in the developer's eye in VS Code, then that's probably the easiest place, or caught by a pre-commit hook regardless of the editor, that's probably the easiest place to change it and fix it. But it is important to kind of consider running, like I said, not just pre-commit hooks and having done with it, put it in CI/CD, work out a strategy for production and runtime scanning of issues that may have already made it through, maybe before you adopted infrastructure as code, or before you adopted infrastructure as code security scanning. There may be issues in your runtime environment that that you want to capture as well. And some of our Bridge Crew SaaS products will help do the same policies in Checkoff against a live cloud account, which helps you kind of bridge that gap if you're interested. But yeah, so Checkoff is designed to pretty much run anywhere and up to this line between CI/CD and runtime. And just to jump into another demo, we've actually just open sourced a plugin which ties Checkoff into VS Code. So if we look at the same TerraGoat repo in VS Code, and again, we're in the Terraform S3 file that we've just been inspecting, everything you would have seen in the Checkoff output is annotated automatically on the resources. So here we have an S3 bucket that allows public read access, which we probably don't want to do, which is CKV AWS 20. Clicking on those will take you to the same guidelines of the URLs in the CLI output, but it does allow developers to click quick fix when we can, and pick an issue and automatically have that put in line with their Terraform. So again, not having to know there's an issue, but actually try and resolve that issue before it even gets committed to anywhere. And as I kind of touched on earlier, not only do we have TerraGoat, but we also have CFNGoat for CloudFormation. And then definitely a shout out to a third-party Goat project is Kubernetes Go, which does an absolutely great job, not only providing a source for testing tools like Checkoff against purposely vulnerable Kubernetes manifests, but this project's gone to such efforts to go through kind of other Kubernetes related hacking and control plane vulnerability exploits, and just really kind of providing a one-stop shop for security learning around the Kubernetes project. So I definitely recommend that as a takeaway to go and check that out. So we've kind of demoed things as we went through, which is quite nice. And, the last thing that remains really for Checkoff is how do you install it? We have it on Brew. It's a standard pip package, so you can just pip install Checkoff. We also have a Docker version, which is built by our CI/CD pipeline that pulls the latest, and obviously you just -- volume mount anything into that you wanted scanning with Checkoff. The guidelines are pulled from an API. There is an option to not pull the guidelines, which means Checkoff can be used completely offline if that's your bag. And again, you can pull custom policies written in Python from your own sources. Talking of integrating into CI/CD pipelines, as I said, we have numerous ways of doing that. Obviously, because it's a binary that will exit with a 1 if there is a failed policy found, or a 0 if there aren't, it fits really easy into pretty much any CI/CD system if you wanted to do that manually. But also we provide things like the Checkoff GitHub action, which allows you to just place it really easily into an existing CI/CD pipeline. And with that, you get things like annotations of PRs and just the ability to have that warm, fuzzy feeling of knowing that your infrastructure as code is being scanned for security issues every time someone tries to make a change. And obviously multiple output formats, which we've already talked about. So yeah, that's Checkoff. That's the first tool, plus the VS Code extension, which we're kind of excited about and would love your feedback on. You know, does it do something you need it to do? Is there anything you would like it to do it doesn't? Like, would love to get feedback on that as a fairly new project. But yeah, Checkoff, we accept any policy update we can. We've got a really active community in slack.bridgecrew.io for all things kind of Checkoff integrations, new policies written for it. So yeah, do check it out. It's got 500 plus policies built in. And we think, you know, in terms of a simple kind of one-click addition to something like a GitHub CI/CD pipeline in Actions, it goes a long way to kind of satisfying a lot of infrastructure security checks. The second tool I want to talk about is AirIEM. And while we have checks in Checkoff for, you know, wide open IAM policies with all of the stars, which I touched on earlier, AirIEM comes from a slightly different angle, and it's more of a runtime tool than a static analysis tool. So AirIEM allows us to dump all of our IAM configuration into Terraform, as well as looking at the current IAM configuration, like many other open source tools can do, pulling the IAM data from the IAM APIs and the Access Advisor APIs, and providing a set of recommendations on, hey, no one's used this account for X number of days, there's been no API activity on this policy, maybe think about removing those permissions. And so AirIEM is designed as just a little utility tool to make kind of securing IAM configuration easier, but not from a greenfield perspective. We appreciate that most people already have things in their IAM configuration, and that's really what AirIEM is designed for. It's designed to find issues that are there, and it's also designed to take a snapshot of your IAM and convert it to Terraform, so that at that point you can continue managing IAM in a, you know, committed to source control programmatic way. And the way we do that is AirIEM actually writes out a Terraform plan file, so that when you run Terraform plan, it thinks it already created all of the IAM resources that already existed, so that you don't have to have that moment where you destroy your IAM configuration and then move it to Terraform. Terraform just quite happily thinks it created those resources, and at that point you can check that Terraform into Git and start kind of, you know, having a programmatic way of going back and looking at changes in your IAM configuration. To that end, actually, let me just quickly find the blog post. We actually used that functionality as a bit of a way of kind of doing IAM drift detection. So by tying the ability to have AirIEM template out Terraform from your current snapshot of IAM, and then storing that as an artifact with a GitHub action, and then looking at the diff between two Terraform snapshots, you suddenly get a very readable description of what has changed between commits in your cloud provider's IAM configuration. You can put that to Slack, you can trigger an alert, just so that someone on your team can check whether IAM should have changed, or whether maybe that's an attempt by someone to gain permissions, maybe that's an indication of compromise and they've gone to try and add themselves a backdoor role or an inter-account role. It's a very good way of kind of summarizing your IAM changes, which generally is one of the most important security parts of your AWS account. So, you know, while kind of the principles of our AirIEM are quite simple, we can Terraform out the code, we can give recommendations, which I'll show in a minute. The actual uses of it with things like GitHub Actions and other CI/CD pipelines, quite powerful. So by all means, give the IAM drift detection blog a read if that interests you at all. Having a quick look at the IAM configuration, it literally takes your, by default, it takes any profile you have in your AWS credentials file, hopefully being used through some kind of temporary set of credentials, and by default find unused will go and give the recommendations. So it will go and query all of your IAM accounts, and we're running this against Acme 3, which is kind of a demo account full of interesting stuff, and you'll see it spitting out a load of recommendations. So here we have, a user that has not been logged into for 109 days, keys that haven't been used for 491 days, so that can be revoked, and a lot of roles that haven't been used either. We'd also catch unattached policies and things like that. The next things you can do with IAM once you have that, and we've actually cached the information coming from AWS at this point, so the rest of the commands will not require you constantly bombarding the AWS APIs. We can then do kind of group reconciliation. So if you have a load of users manually bound to a load of their own policies, we'll go through and find common policies attached to multiple users and recommend kind of grouping using user groups in IAM, so that you're not having to bind every user to a policy, and kind of recommend where policies can be removed in favor of adding a policy to a group. And then the thing I was talking about with drift detection is we can spit out Terraform. And we can spit out a Terraform with or without a plan file. Spitting it out with a plan file will take longer because we have to go and query even more data than is in the cache to make sure we can trick Terraform into thinking it built these resources. But what you will end up with is a Terraform file that you can do Terraform plan on, and it will go and happily say, nope, there are no resources currently in need of changing, because it believes that that current state is something it built. Which again is really useful, because a simple Terraform plan against that plan file will then alert you if there's any resources that suggest changing. That is an alert of drift, even if you don't want to take the two Terraforms and diff them for readability. A Terraform plan based on that plan file will tell you if there's anything changed in your IAM configuration. So while we won't go and let it run the Terraform plan for 469 items, that was a quick whistle-stop tour of IAM. So Checkoff and AirIEM were the two tools that we're super excited about kind of evolving and maintaining and adding more and more functionality. The ability to automatically template out Helm manifests and then scan those against our Kubernetes checks was actually committed this week. We have the ability to scan Terraform plan files rather than just Terraform, again for variable resolution. And we're working hard to add more and more parsing logic to deal with kind of more complex loops and variables and other types of infrastructure as code manifests. So definitely give Checkoff a try. I would love to hear feedback on whether you find it useful, what extra policies you think we should be checking by default, things like that. We also have a AWS workshop, which is very much focused on automating security around AWS, using kind of AWS tools like code build, code pipeline, and also, looking at some of the runtime scanning stuff we talked about there from a bridge crew perspective. So kind of checking infrastructure as code, whether any of these issues we're checking for in Checkoff have actually made it into a real life cloud resource. So if that interests you, definitely check out bridgecrew.awsworkshop.io, where we have not only the content, but a video on YouTube of us running through that as a live workshop. And then, feedback, thoughts, comments, exciting ideas for either of these projects. Join us in Slack or reach out to me at MetaHertz on Twitter. And thanks for joining in AWS Community Summit, and hope you found this useful. Thanks very much.